Welcome to EDU World Space.
So to answer this question, since there is no recoil of the radon nucleus after the decay of the alpha particle, the energy of the alpha particle must be equal to the potential energy of the alpha-radon combination. So the potential energy of the alpha-radon combination just before the decay is V is equal to 4 point, hold on, let me just check real quick, 4.79 MeV. So this is actually just straight from the question because it's given to us. But now we need to find out the potential energy, which cannot be in EV. So we need to convert the units. So U is equal to 4.79 MeV. So let's just get rid of the mega by just multiplying it by the 10 to the power, by its equivalent 10 to the power negative, 10 to the power positive 6, since it's mega, not, yep. All right, so there we go. And now the conversion is that 1 EV is equal to 1.6 times 10 to the negative 19 joule. So now if you're just converting into joules, which is the units for potential energy, so we can get that by multiplying this times 1.6 times 10 to the negative 19, which is just the conversion for EV to joules. And if you do that, we're going to find out that the potential is 7.664 times 10 to the negative 13 joules. So that's the answer to part A. Let me just make sure that we're clear. That is part A. Now moving on to part B. We know that the potential energy of a system of 2-point charges separated by a distance r can be found by this equation. So U is equal to Coulomb's constant, K times charge 1 times charge 2 over the radius. So now if we just plug in, actually before we plug in anything, we need to convert the charges from MeV to joules. So the charges that we're given, or the information that we're given, is that the radion nucleus contains 86 protons and the alpha particle contains 2. So we need to find out the charges instead of knowing the number of protons, and it's actually very simple on how to do that. So let's do that on the side over here. So we know that the nucleus has 86 protons, so it's just 86 times the charge for a proton, which is just 1.6 times 10 to the power negative 19. So this is just call this the charge 1, Q. So Q is equal to so let's just not compute them right now. Let's just write this out so we know that the expression, we know how to calculate the charge from the protons, from just the number of protons. We actually don't need to calculate it, since we can just plug it in here and calculate it all together at the end. So the second charge, the alpha particle, has 2 protons, so it's 2 times 1.6 times 10 to the power 19. Let me just redo that line over there. Yep, times to the power 19. So now if you just plug all of this back into this main equation and we compute it, so it's Coulomb's constant is 9 and the first charge is 86 times 1.6 times 10 to the negative 19. We can actually just since both charges have 1.6 times 10 to the negative 19, we can just factor that out and then add the 2 proton values. So it's just 80. Let me get rid of that 2. So it's just 8. So it's just 86 protons plus 2 from the small charge times this times Coulomb's constant over the radius, which is given to us. Hold on, let me just check that real quick. Yep, I messed up. Sorry. So we're actually finding the radius. So we can actually use this in the sense that we know the potential. I'm sorry, I don't know how I forgot about this, but we calculated the potential in the previous step, and we're actually looking for the radius in this step. So now, if we just in this first step, if we just cross multiplied and swap the places of the potential energy and the radius, we can isolate for the variable r and solve for the radius. So if we do that in the second step here, we're going to find out that the radius r is equal to all of this over the potential, which is just equal over the potential, which is just equal to 7.664, I believe. Let me just write the sixes a little bit better. So 7.664 times 10 to the negative 17. Negative 13, sorry. And if we compute this in our calculator, we're going to get that the radius is equal to 51.6. Hold on, let me write the 6 a little bit better. 51.6 times 10 to the negative 15 meters. And that's it for this question.